a force on a charge moving in the field. Figure 433, force on moving electron in magnetic field V at right angle to the page. If the electron in wire trapped with average velocity V and the wire lies in the magnetic field B, the force F on each electron E is given by F equals to BeV sin theta, equation 1, where theta is the angle between the magnetic field B and the direction of motion of the electron E. Generally, for a moving charge, the equation 1 becomes F equals to QVB sin phi, equation 2, where V and B are at right angle, or phi is equals to 90 degrees. Then sin phi is equals to 1. Therefore, the equation 2 becomes F equals to QVB. If magnetic induction B is in Tesla T, Q is in Coulomb C, and V in velocity in meters per seconds, then F will be in Newton. Example 1. Find the project into a magnetic field of flux density 10 Tesla with a velocity of 2 times 10 raised to the power 7 meters per second in a direction at right angle to the field. Charge on an electron is equals to 1.6 times 10 raised to the power minus 19 coulombs. Solution. Since velocity V and magnetic field B are at right angle, we have that F is equals to QVB. F is equals to 1.6 times 10 raised to the power minus 19 times 2 times 10 raised to the power 7 times 10 is equals to 3.2 times 10 raised to the power minus 11 Newton. Thus, the magnetic force is small compared with the gravitational force, which has been calculated to be 8.8 times 10 raised to the power minus 13 newtons. Example 2. A beam of iron passes undeflected through two parallel horizontal plates 1.5 cm apart, having a potential difference of 3000 volts, when a perpendicular magnetic field of 10 raised to the power 2 Tesla is applied, and in the magnetic field alone the beam is bent into curves of radius 2 meters. Calculate the charge mass ratio of the ions. Solution. Since the beam is undeflected, the force due to magnetic field is equals to force due to electric field. BeV equals to EE. V is equals to E over B. Making V the subject, we have now, and substituting the value, you have 3000 over 1.5 times 10 raised to the power minus 2 times 10 raised to the power minus 2, which is equals to 2 times 10 raised to the power 7 meters per second. In magnetic field alone, BeV is equals to mv squared over r. Therefore, E over m is equals to V over rb. E over m is equals to 2 times 10 raised to the power 7 over 2 times 10 raised to the power minus 2, which is equals to 10 raised to the power 9 coulomb per kilogram. Example 2. A beam of light passes undeflected through two parallel horizontal plates 1.5 of light passes undeflected through two parallel horizontal plates 1.5 cm apart, having a PD of 3000 volts, when a perpendicular magnetic field of 10 raised to the power minus 2 Tesla is applied, and in magnetic field alone the beam is bent into a curve of radius 2 meters. Calculate the charge mass ratio of the ion. Solution. Since the beam is undeflected, the force due to magnetic field equals to the force due to electric field. BeV equals to EV. Therefore, V is equals to E over B. V is equals to 3000 all over 1.5 times 10 raised to power minus 2 times 10 raised to power minus 2, which is equals to 2 times 10 raised to power 7 meters per second. In the magnetic field alone, BeV is equals to mv squared over r. Therefore, E over m is equals to V over Rb. E over m is equals to 2 times 10 raised to power 7 all over 2 times 10 raised to power minus 2, which is equals to 10 raised to power 9 coulomb per kilogram. Electromagnetic field. Transformer. In a transformer, an alternating current flows through the primary coil, giving rise to change of flux around the primary and secondary coil, giving rise to an induced EMF in the coil. Transformers set steps voltage up or down according to its turn ratio. From energy conservation, we have that transformer formula: secondary voltage ES over primary voltage EP equals to secondary turns NS over primary turns NP, or ES over EP equals to NS over NP equals to IS over IP. The above equation holds where the transformer is assumed to be 100% efficiency. Example 1. If the efficiency of the transformer is 80% and the current in the secondary is 10A, calculate the current in the 240 volt supply. Solution. Let LP be the current in 240 volt supply. Power in the circuit equals to IV. Power in the primary equals to IP times 240 watts. Power in the secondary equals to 10 times 240 watts. Efficiency is equals to output power over input power. That is 80%, which equals to 10 times 24 all over IP times 240, or 80 over 100 is equals to 10 times 24 all over IP times 240. 80 times IP times 240 equals to 100 times 10 times 240. IP is equals to 100 times 24 times 100 all over 80 times 240, which will give us 1.25 amp. Example 2. A transformer has 300 turns of wire in the primary coil and 30 turns in the secondary coil. If the input voltage is 100 volts, find the output voltage. Solution. Number of turns in primary coil MP equals to 300 turns. Number of turns in secondary equals to 30 turns. Let EMF of secondary be E, be X. EMF of primary EP equals to 100 volts. From ES over EP equals to NS over NP. 30 over 300 is equals to X over 100. 300S is equals to 30 times 100. X is equals to 30 times 100 over 300, which is equals to 10 volts. The output voltage is equals to 10 volts. Example 3. A transformer 5,500 turns in each primary is used between a 240 volts AC supply, a 120 volts kettle. Calculate the number of turns in secondary. Solution. Use the formula EX over EP equals to NS over NP, but NS equal to number of turns in secondary, which is unknown. NP is equal to number of turns in primary, which is 5,500 turns. ES equals to EMF of secondary, which is 120 volts. EP equals to EMF of the primary, which equals to 240 volts. Therefore, NS over 5,500 equals to 120 over 240, Making ns the subject of the formula, we have